Hello everybody. In this video, I'm going to show you how to calculate the axial displacement by the principle of superposition. The principle of superposition says the response caused by two or more forces is the sum of the responses that have been caused by each force individually. It's like if you want to know what's going to happen when a person carries 20 pounds on the left and 20 pounds on the right, you can analyze the same person doing the weight only on the left or only on the right. Then in the end, you combine the two situations. That would be equivalent to the one person carrying the weight on both hands. So now let's look at the problem we have. We have a beam, cantilever beam, AD. There are 3 point loads, P1, P2, and P3. Based on the principle of superposition, the 3 loads applied on the beam AD is equivalent to P1 applied at point B. That's loading case 1, plus loading case 2, which is P2 applied at point C, plus loading case 3, which is P3 applied at point D. Now, to solve the displacement at point D, we will need to calculate what are the individual displacements caused by the individual loads. So I will call the first displacement as delta D1. This is the displacement caused by P1. P1, this force is going, the force P1 is only causing stress in the segment AB. In segment BC and CD, there is zero stress, although everything is going to move to the right-hand side. That amount will be delta D1. This amount is calculated as P1 L1 over EA. And in this calculation, I will assume right-hand side is positive. If the point moves to the right, that's a positive displacement. If the point moves to the left, that's a negative displacement. Now, what's the value for delta D2? It is P2 times L1 plus L2 divided by EA. And this is a displacement to the left, so I will give it a negative sign. In this case, we only have stress and strain in between point A and point C. The stress in CD segment is 0, so we don't need to consider L3. In the last case, P3 is going to cause stress and strain in all 3 segments. Delta D3, this is a P3 times L1 plus L2 plus L3 divided by EA. Now, let's look at what's the combined effect of the 3 individual loads. The overall displacement delta D is P1 L1 over EA plus negative P2 L1 plus L2 divided by EA. And then the last part is P3 L1 plus L2 plus L3 over EA. So this is the displacement at point B caused by 3 point loads P1, P2, and P3. Now, if I ask you what is the displacement at point C caused by the 3 loading, how would you calculate that? Delta C. Let's look at the 3 individual loads. When we look at P1, P1 is going to cause the stress and strain in AB portion. So the moment caused by P1 will be the same. It's P1 L1 over EA. How about P2? P2 is going to cause stress and strain in between AC segments. So it will be the same result here is minus P2 L1 plus L2 divided by EA. How about P3? P3 is going to cause stress and strain along the whole length of the member. That's from point A to point B. but we're only interested in the deformation at point C. In this calculation, the lengths we're going to use are just L1 and L2. We don't really care how L3 is changed. Then the calculation here will be P3, L1 plus L2 divided by EA. This is the displacement at point C. Now, if I want to know what is the deformation at point A, how would you calculate that? The equivalent system we are looking at will be this. This is A, this is B. Then we have P1, we have P2, and P3. Right? If we are only interested in the deformation at point B, then the member length BD doesn't really come into the equation. So the result will be P1 minus P2. Sorry, this should be P2. P1 minus P2 plus P3 times L1 over VA.